I'm sure a lot of you are facing this issue that you are memorizing all the formulas, you are going through all the concepts that are there, but even after that, you are not able to score well at the tests that you are taking. Now, there are many reasons to do that, and simply memorizing formulas is not going to take you anywhere deeper than scoring a few marks here and there. Now, you have to understand a few things. You have to understand to learn the boundaries of the formulas that you are applying. So, let's say, for example, you learn Pythagoras theorem, which says a square plus b square equals c square. Now, that is the boundary of this particular expression. But you also have to know what happens if it is not equal to c square. What if a square plus b square is greater than c square? What if a square plus b square is less than c square? Does it change the nature of the triangle? Yes, it does. So instead of just buying whatever formula has been told to you, just understand what are the nuances, where can we apply the formula, where can we not apply the formula, how can we understand how to derive that particular bit, and you should be better in terms of application of the formulas. So learn the boundaries of each and every concept slash formula that you come across. Also understand the why beyond a particular formula. A lot of you would say that, okay, if you want to find the LCM of a number, you have to look at, or LCM of a set of numbers, you have to write down all the numbers as a product of their constituent primes. You have to write down all the primes such present and then raise them to the highest power that are there. Now, why the highest power? Why not the lowest power? What happens if you raise it to the lowest power? You get the HCF, of course. But why is that the case? Also, in terms of, let's say someone tells you that if you add all the digits of a number, you can figure out the remainder when you divide that number by 9. Now, why is that the case? Why do we have to add the odd placed digits and the even placed digits and take the difference when it comes to figuring out whether a number is divisible by 11 or not? So you have to understand the why behind most of the formulas. If you are able to understand why a particular thing exists, you will also be able to figure out what are the boundaries and the fringe cases that rule out that particular formula. Also, you have to understand how to build intuition. Now, intuition essentially means in this context that you should be able to derive the final formula. Let's say, for example, you do not know how exactly does this formula come into the picture, that let's say there are two people who are traveling in opposite directions. They meet each other, and after that one person takes A hours to reach the end point and the other person takes B hours to reach the end point. Now, if I want to figure out the ratio of the speeds of S1 and S2, the first person and the second person, it is going to be root of B divided by A. Now, why did this formula come into the picture? So if you're not able to memorize it, or you're not able to figure out why exactly is this happening, you also have to understand the proof, which helps you build the intuition, and it will take you one step behind where you should be. And then you will be able to figure it out. So case in point, I mentioned a square plus b square less than c square earlier. Now, if you are not sure whether it is for acute angled triangles or obtuse angled triangles, you can have a fail-safe in your brain which tells you that look at a 2, 2, 2 triangle, which is an equilateral triangle. So because it is an equilateral triangle, it is also an acute angled triangle. Now, if you do 2 square plus 2 square, you are going to get 8. Compare it with 2 square, this will be greater. So you can confidently say that if a square plus b square is greater than c square, where c is the longest side, then you will know that you are dealing with an acute angled triangle. And finally, of course, the obtuse angled triangle bit also falls into place. So that is basically how you build intuition. You basically go one step back and then try to figure out what the formula should be. So build that part and you will not miss out on any application of formulas. You have to create concept maps as well. One of the things that I advise people who are not good at the subject is, imagine that you're teaching it to someone. Because when you are trying to teach a concept to someone, that is basically where you have to learn what the concept is. You also have to understand what kind of questions can be asked to you. And that is how you create concept maps. So instead of just saying, okay, there was a question on alligation rule, you have to understand that we are dealing with arithmetic first, okay? Then we are dealing with this bit called weighted averages. Then in terms of weighted averages, if we want to find the ratio of the concentrations, then maybe alligation rule comes into the picture, and that is basically how you apply the alligation rule. So that is the concept map that you are trying to apply. If you are looking at installments, let's say, you try to figure out what can be the traps that are there. You are trying to figure out what all can be the variances that can exist. Is it EMI or can the EMIs differ? So that is basically where you create concept maps, wherein you are trying to figure out what all are the branching patterns. So let's say you get into installments. My first instinct will be to figure out whether the installments are equal or not equal. If they are not equal, then my numerators will change. If they are equal, then my numerators will remain the same. Similarly, in terms of any other concept that you're applying, let's say simple interest and compound interest, I will try to see what the trap is. Is the interest getting generated every 3 months or 6 months or 1 year? and accordingly how will the time period change. So all those things have to be considered when I am creating concept maps, and that is how I will understand which concept to follow, which branch to follow, and what all can be the traps there. You also have to visualize the path to solution. Okay, now you have identified that this is basically the problem and this is the thing that has been asked. This might be the formula that might be useful. You have to visualize the path to solution. You will try to look at maybe the numbers that are there. You know that your answer is a multiple of 7. You will check the options for multiples of 7. If the answer is not, or if multiple options are there that are multiples of 7, then what will you do? So you have to visualize these paths when you are solving a question, and it works like an algorithm. My first instinct is to check whether the numbers or whether an option is there that is a multiple of 7. If yes, I will reverse engineer and see if the other elements are true. If not, I will have the conventional method in front of me that will help me solve the question. Once you have this algorithm in place, you will be able to execute it almost flawlessly. So that is basically what it takes to be able to crack the quant section of the CAT. It is not just about knowing concepts, knowing formulas, because everybody has access to the same formulas, the same concepts that are there. So there's this one quote that I tell everybody: top scorers don't know more formulas than everyone else. It's not going to happen. They simply understand the formulas a bit more deeply, and they are able to apply it in a slightly more flawless manner. And that is basically how learning should be done, especially in terms of quant. If you know the whys of the things that are there, if you know the intuitive nature using which you can arrive at a particular formula, I think you would have done a great job when it comes to quant. There is one small bit in terms of interlinkages that you will understand once you get good at this particular section, and you will be able to tell me that, okay, in a time speed distance question, you can also apply the alligation rule. And that is basically the day when you would have done really well at the quant. Now, if you have any doubts in terms of the section, do let me know in the comment section. We have some very nice programs for quant. So do check them out in the description box below. And if you have liked the video, do leave a like and stay subscribed to this channel for more such engaging content.